So on these first two slides, we're going to look at our translations. And what I'm going to do is I'm going to underline our propositional letters with red, and then looking for our keywords that indicate what our operators are, I'll underline with blue. So looking at this first sentence, we have two propositional statements about having a cat and having a dog. So we already know that we're going to have a C and a D. The next part we're going to have to figure out is what our connective is. And here, if I can get my, there we go, is our and. So an and, but, those are all statements that are associated with a conjunction. So we'll use our ampersand. So any and or but, those will be an ampersand there. Looking at the next one, we have J and T. We have J for Ja'Marr Chase and T for T. Higgins. What's our connective going to be? Well, we've got an either or here. So here we've got either or, and our either or statements are connected with a wedge. Looking at our third one, since I've got the blue already turned on, let's look for our connectives. We got an if-then statement. We've got an and here, and we've got another and here. So we should expect to see two ampersands and an arrow. And then if we're looking at what our propositional letters are, we've got P for Pedro Pascal, A for Anne Hathaway, W for watching the movie in the theaters, and B for buying the DVD. So to symbolize this one, we have P and A together, and then W and B connected by the arrow. So how do I know that the arrow is outside the parentheses? Well, here a good indication is that we have a we have a comma right here. And whenever you see a comma, that's usually a good indication that whatever happens before the comma is going to go in a parenthesis or set of parentheses, and then whatever comes after the comma is going to be in its own set of parentheses. So that's one good indication here, but also if you're just trying to understand the content of the sentence, if the movie stars Pedro Pascal and Anne Hathaway, so they both have to be starring in the movie. So I know those two go together, and then the second part, I'll watch the in theater and buy the DVD. Just by the way in which that's phrased, it sounds like both of those things also go together. So you can use the comma as a good rule to figure out where the parentheses go, but you can also just think about what the content is trying to convey. Looking at this fourth example, we have our propositional letters of P for PETA, K for Katniss, and so what's our connective here? The important thing with this example, if I can find my cursor, is to not get not see the if statement and automatically think it's just going to be a regular conditional statement. So, oops, sorry, there it was. So here we've got an if and only if statement. Let me erase that so then it's that. There we go. So we've got this if and only if statement, and that's got to be represented by a biconditional. So we've got just P double arrow K here. All right. Since I got my blue clicked on again, I'm just going to go with here. So looking at this fifth example, I have an and, I have an or, and then I have another and. So I already know that I'm looking for three different operators. I've got a B for blue jacket, yellow for yellow shirt, W for white jacket, P for purple shirt. And you might notice here again we've got a comma, so that should tell us which direction or what the groupings will be for the parentheses. So anything on the left side of the comma should be grouped together, anything on the right side of the comma should be grouped together. And again, if you're just thinking about the content of the sentence, it makes sense. I mean, I would be wearing a blue jacket and a yellow shirt if we've got the symmetry on the other side of a white jacket and purple shirt. On this slide, we got a couple of tricky examples here, and some of these you won't necessarily see number 6 or number 9 in the future, but I want you to be aware of how we would symbolize them because it can get a little difficult. Looking at 6 first, so we have two different propositional letters with C and P, but the sentence also implies that they're both going to be here again at the end. So they're actually going to appear twice. That's what makes this one a little bit tough. Well, let's look at our connectives. So we're going to have an or, and we're going to have an and we're going to have a not. So for this one, also you might have noticed that we've got a comma here. So it's going to indicate that we're going to have some set of parentheses. One set going to the left of the comma, one set going to the right of the comma. So we actually end up with something like this. This one's a little bit tricky because you might have thought, hey, shouldn't, let me get my blue here, shouldn't this tilde also be over here and have the parentheses out this way instead of here? This statement, as it's written, would be that you're not learning C++ and you're not learning Python. When in reality, what we want this sentence to say when we're symbolizing it is that you're learning one, but you're not learning both of them. So if we keep it the way in which we wrote it the first time, what we get is something that says on the left-hand side, I'm learning either C++ or Python, but that's our ampersand. So our but is this here. I will not, so not being our tilde here, learn both. And then both is implying a conjunction. So that's how we would ultimately formulate this sentence or symbolize it. It's tricky because you might not be as sure about what to do with the tilde. But here, since we're not saying not both, the tilde goes outside the set of parentheses. Also remember that you have to have some connective or in between the left and right conjunct here. So you can't just write the negation as the as the connective between C wedge P and also C ampersand P, because the tilde only negates whatever it's connected to. It's not actually some operator that connects two different parts of a sentence. So the ampersand is pretty crucial here too. Like I said, that's a little bit more difficult than what we'll do on a regular basis, but it's important to also recognize that the tilde is going with the parentheses and not actually connecting as the main operator. Okay, looking at the next one. So we have a V for your dog does not want to go to the vet, and a P for but your dog does want to go to the park. So we've got a couple of operators here. We've got the not and we've got the but. So this one would be symbolized as this. So again, it's important to recognize whether or not you need parentheses. So for this one, if you were to include a set of parentheses, then what you're saying here is that your dog doesn't want to go to the vet it doesn't want to both go to the vet and the park, which would be something different than what that sentence actually says. It's trying to say your dog doesn't want to go to the vet, but it does want to go to the park. So important to realize here that the tilde only applies to that V. So let me erase that. Looking at number 8 here, so we have a phrase that's important to keep in mind. So it is not the case that means that whatever comes after this is going to be put in parentheses and it's going to have a tilde in front of it. Anytime you ever see the phrase it is not the case that, it's suggesting that everything afterwards is being negated. So that's one indication that we're going to need a tilde. We have an and here, so we have our R and W for rainy and windy, so we get this formulation. So the tilde is applied to the entire statement. It's negating this idea that it's going to be both rainy and windy. So it's not the case that it would be both rainy and windy. So that's why we put the tilde outside the parentheses. All right, let's finish with the most difficult one, and this is one that I will not necessarily expect you to master, but it sort of drives home an important point here. So here our words are neither nor. That would be indicating our operator, and you might think, well, neither nor implies a negation, and it also implies a wedge or a disjunction, which, I mean, that's right. But even though those are two components there, it may not be obvious how those are being put together. So we have R and P. So you can actually symbolize a neither nor statement in two different ways. Both of these are logically equivalent. Originally, people think, oh, it should be a wedge here. Let me see if I can get it on the screen. There we go. So a lot of times people think this should be a wedge, but really that's just saying it's not one or it's not the other one. When in reality, what we're saying is that neither of these teams are going to be the ones that are going to win the NL Central. So the ampersand is the correct operator for this situation. If you want to use the wedge, then you have to set a set of parentheses around the R or P. Why is that? Because you're negating that whole statement that it's either one or the other, when in reality it's not the case, that's either one of them. So again, that's a little bit above what we're going to do in this class, but I think it's important to see that there are different ways to formulate a sentence on occasion, and neither nor is a pretty good example, and that these sentences or these symbolizations of the sentences or of the sentence is logically equivalent. Now let's move on to truth tables, and we're just going to look at individual statements. Next time we'll look at multiple statements for arguments and testing those arguments for validity. Here I just want to go over the basics of a truth table. So here at the top of the screen you'll see our rules. I just put these here on each slide just so then you're aware of them. Again, I use squares and circles typically when I'm giving the rules, because anything can stand in for a square. So this square can be a P and this circle can be a Q, but just as easily that square can be an R, and this circle can be a T, or they can be complex sentences. So that's the reason why I give these meta variables, that's what we call them, in the rules, just so you know that they can stand in for just about anything. So I gave you the rules at the top of the screen for each of these, just so you can see as we go by. You don't have to list them every time that you're doing a truth table, but just there for your own usage. So looking at the truth table here, so what we're trying to do is determine the truth value of this statement. Before we get to evaluating that, you see over here that we have these two blacked out columns, this P and Q, and you have truth values already plugged in here. Those truth values are already plugged in because this is like our key. They're called guide columns, and what they do is they make sure that we have every combination of truth values. So we have a case in which we have true, true, false, true, true, false, false, false. That's all this is just telling us what this row is supposed to be associated with in terms of the combination of truth values. And so these two guide columns, that's all they're doing, is just letting you know what's happening in that row. So don't let it confuse you. Now let's turn to our sentence here that we are actually determining the truth value for. Now it's important to determine what the main operator is. So what is the operator that's operating over the whole sentence? That's what I'm meaning here. And so in this case, our main operator, let me clean this up for a second. Our main operator is this arrow here. Why? Because this is our square, this is our circle. So we have to do this side and this side before we can determine the truth value of the main operator here. So we have to work from the smallest to the largest operator, and in this case the tilde connected to the Q, that is our smallest operator. So we got to start there. So let me clean this up. What we're going to do is we're going to take our values from our guide columns here and determine, so you can just like ignore this part. We're only focusing on this tilde Q. And so the tilde rule, if you look up here, is to just flip whatever the truth values are. So if you've got true, then you get false. If you got false, then you get true, true, false, false, true. Right. So all we're doing is flipping these values from a true to a false, true to a false, false to a true, false to a true. Right. Then once we get that column, for that operator, I guess I should say, then we can look at our main operator, which is our arrow here. So to determine the arrow, we need our our right side, which we already calculated, and then our left side is our P. So we're just going to take these values here. So I'm just going to take all of these values and copy them. So I've got a T, I've got an F, T, F. Right. You don't actually have to copy these over. I'm just doing it so you can see where we're getting those values from. So we're just going to look at what it says for the P. And so let me clean this up for just a second. Right. So now we're looking at comparing, there we go, these ones and these ones. So if we have a true antecedent or a true left side and a false right side, what's that going to be? Well, if we look up here in our rules for the arrow, if the left side is true and the right side is false, then it's false. So that's what we've got here at the first one. And then if we've got false, false, then it's true. If we've got true, true, then it's true. And if we've got false, true, then it's true. And at the end, let me clean this up one more time. When you're reporting the truth value for the sentence, you actually don't want to include this column at all. This was just something that we included to help us figure it out, do the evaluation for that main operator. So the only thing that you want to give for your answer is this column right here. For this one, we have three different operators. We have a wedge, an ampersand, and a tilde. Again, the first thing you should be thinking about is what's the main operator out of those three. In this case, it's going to be the ampersand. It's connecting this side and this side. So we have to do the P wedge Q and the tilde Q before we can derive what the truth values are for this ampersand here. So let's do those. It doesn't really matter the order that we figure those out because they're sort of on the same order of operators here, but we can just look at the wedge first since it's on the left hand side. So the wedge rules, which we can find up here in the table, right? We've got a wedge is true anywhere that at least one of the sides are true. So both sides are true here, one side's true here, one side's true here. The only place that it's false is where both disjuncts, or the left side, right side of the wedge, are both false. So that's why we get these values here of true, 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 false. That's why they actually match perfectly with what's in our rule table up here. So that's the first one. Let me get rid of that. All right. And then with our tilde Q, it's just reversing the value of Q that's in our guide table. So any T becomes an F, and any F becomes a T. So F's become T's, T's become F's. Then, now that we've got our left side and right side, our main operator is the ampersand. So let's go back and look at our ampersand rule, which is up here. So an ampersand is true only where my left side and my right side, or my left and right conjuncts, are true. Anywhere else, as long as one of the conjuncts are false, then it's automatically false. So that's why we only see one case in which it's true, which is the top row with both of them being true. So we're looking for any situation here in our truth table where both sides are true, and I only see one, which is right here. The rest of them, here's a false, here's a false, here's a false. So it should be false, false, true, false, which is what we get. And then just like before, let me clean this up. We don't need these. The truth values for this statement is just this last column underneath the ampersand. Okay, now moving a little bit quicker on this one, you can see that for our statement here, we've got two different operators. We've got the tilde and we've got the double arrow. Since the tilde is outside the parentheses, then we need to do the double arrow first because our tilde is our main operator. So for our double arrow, we can look up here for the rules. So the rules for a double arrow is that wherever they match, it's true. So if both sides match, or sorry, if both sides are true or both sides are false, then it's true. But if they don't match, then they're false. So here we can just fill this in based on our rules. We got true, false, false, true, because it's the same setup as up here in our guide, or in our rules table. So those are the derivations for just the double arrow, but then we also have to do the negation here, which will ultimately just flip the values from trues to falses and falses to trues. So all we're doing is taking our T, changing it to an F, F to a T, F to a T, T to an F. The negation, or the tildes, are pretty simple and straightforward. All you're going to do for them is flip the value from one to the other. So this one's not too bad. Now let's move on to some examples with three propositional letters P, Q, and R. Don't let it overwhelm you. The only difference here is you just have to be a little bit more careful in what letters you're using to figure out the different derivations for. So this one here, we have three different letters, but we only have two operators. We have an ampersand and we've got an arrow. The ampersand is inside the parentheses, so we know we're doing that before we're doing the arrow. So we're going to use the P values and the R values. And so what we get are these combinations here. And you can see that the only places in which we have a true value are these two rows, because both P and R are true in those rows. And every other row, at least one of them is false or both of them are false. So that's how we get these. Just be careful that you're using the P and the R and not just the P and the Q or the Q and the R. You have to make sure that you're using the correct letters. So P and the R are getting used here. That's the truth value. Those are the truth values we get for the ampersand that's inside of the parentheses. And then after that, then we can figure out our truth values for the full statement. So we're going to use the Q. Let me get that. So if you want, you can fill all of these in underneath this Q. I won't, because I'm not going to be able to do it very well with this mouse, so I apologize. But if you want to put more notes in here of like TTFF, TTFF, just copying these rows down underneath this Q to help you out, it's totally fine. But if we're looking at this arrow, remember that for an arrow statement, the only place in which an arrow is false is where our left side is true and our right side is false. So let's look for any case in which our left side is true and our right side is false. I see one right here in this third row, because I've got a true antecedent and a false consequent. Let's see if I've got any others. I don't see any others. So we should only have this one instance of a false, which you see here, and then the rest of them are true. Another case in which we've got three different letters here. Now we've got three different operators. So we've got a wedge, a tilde, and a biconditional arrow. So same thing as before. We've got this wedge that's inside the parentheses, so we need to start there. And then once we finish that, then we need to look at this tilde, because this tilde is only operating over that disjunction or that or statement. And then we can move on to the whole statement that's held together by this biconditional. So let's start with the wedge. So I'm going to do like I did on a slide before. I'm just going to, just as a visual here, ignore all of this. None of this matters right now. So our P or Q is going to be true everywhere where at least one of the disjuncts or one side is true. So the only case in which it's false is where both sides are false. So let's just look for cases like that. So I've got my P and Q here. Oh look, fourth row, I've got both of them false. Oh, eighth row, they're both false. So I know that those are the only two places in which they're going to be false. Everywhere else it's going to be true. So we've got that figured out. Now let's move on to our negation. And so I'm going to do like I did before. Just ignore this R and ignore this biconditional and just focus on that. So for the negation, we're just going to flip all these values. Any T becomes an F and any F becomes a T. So T's become F's, F's become T's. pretty straightforward for the tilde. Just flipping whatever the truth value is to the thing, or of the thing to the right of it. Now, you don't need this row anymore, so you should just ignore this, because the only reason we needed, or sorry, not this row, this column. We don't need this column anymore. It's only going to confuse us, so let's just erase it. And I'm going to erase what I wrote here. And just to drive home the point, the reason I'm erasing it is because this, I don't want to use blue. I'll use, I probably don't want to use purple here. I'll use green. Because these values underneath represent this whole statement to the right of the biconditional. So we don't want these extra values here confusing us. That's why I just scribbled them all out. Only these ones in which I have circled in green, those are going to be the truth values for tilde, P, or Q. So hopefully that makes sense. So I'm going to erase that. And then the next thing I want to do is think about the R. Again, if you want to copy all the values of R underneath R, you're totally welcome to do that. It could be helpful, but you don't necessarily have to. And if we look at our rule for double arrow, the double arrow is true wherever both sides of the biconditional are true or both sides are false. Everywhere else it's going to be false. So let's just look for places in which they match. I've got true, false, that's not matching, true, false, that's not matching, true, false, that's not matching. Oh, I've got true, true. So I bet that one's going to be true. False, false, that one should be true. They're matching. That one should be matching. Or sorry, that one should be true because they're matching. Those ones are matching, so that should be true. And then false, true. So we've just got these lines here where they match. And if we look at our values where they come when they're calculated, so yeah, we got false, 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 true, 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 false. And once again, I guess I should say, is let me erase that. Once we get these values, we don't need these anymore. They're not necessary. They were just there to help us get the truth value of the statement. So these are the truth values for that statement. Okay, let's finish up with this last example. Again, we've got three different propositional letters, P, R, and Q. We have three operators, tilde, wedge, arrow. The arrow's inside a set of parentheses, so we know we got to do that first. But the tilde that's connected with the P, that's also on the same level as this arrow. So we can do either one first. We can either do the tilde or the arrow, just as long as we do both of them before we get to this wedge here. I just decided to do the tilde first because reading left to right, it just made sense to me. So focusing on the P, the tilde P here, ignore all of this for right now. Right. We're just flipping the values of P so that T's become false and falses become truths. And it's the same thing all the way down the rows here. So again, tildes are pretty simple. Just flip whatever the truth value is. Now if we look at the conditional statement, so just ignoring all of this for right now, here's where things can get a little bit confusing because our R is our left side and our Q is our right side. So you can't just read the guide columns left to right all the time. You have to be careful about what truth values you're comparing. So this is actually our left side and this is our right side. Or if we're looking up here in our rules, the Q is our circle and our R is our square. Sorry that those are not great shapes, but that's the idea here. And if we're looking at our arrow, where is an arrow false? Well, it's only false in one row, which is where the left side is true and the right side's false. So let's just look for cases in which we have a true antecedent or a true left side, and situations where we have a false right side or consequent. And where do we have the matchup? Oh, well, we have a matchup here. So those two rows should be false, and the rest of them should be true, and that's what we get. Now that we have our two disjuncts, the left and right side of our wedge, let me clean this up. Now we can look at our complete statement and determine the truth values. So we're looking for a wedge. What are our wedge rules? Well, our wedge is true everywhere except for one situation, and that's where our left side and our right side are both false. So let's look for cases in which we have both a false left disjunct and a false right disjunct. And I only see one case, and that's right there. So everywhere else it should be true. We've got false true, that's true. We've got true true, that's true. Our false false, that's false. True false, that's true. False true, that's true. True true, that's true. False true, that's true. True true, that's true. So we only got the one case in which it's false. And then just one more time here. We don't want these two columns. We only want the center column that's associated with the wedge. So these ones can go away. And we're just left with that center column in black.